Hello, algebra students. We are going to do the ALEKS graphing calculator quadratic function demonstration. So I'm going to start on assignment 7.1 with a demonstration of question 3. So I'm going to open up my ALEKS graphing calculator, and it is asking me to find all of the real zeros. The zero is it's a fancy way of saying X-intercept. So the zero of a function, the x-intercept of the function, those are the same thing. So we're going to start by going to y equals and typing in our function. So it's 4, and then I'm just on my keyboard just going to type an x, like the letter x. Then I'm going to use my exponent button to the left of 7 to do a second power, arrow to the right, and then just type minus 2x, and then minus 4. I'm going to hit graph, and there's my parabola. The zeros are going to be the x-intercepts. Sometimes there will be 2 x-intercepts. Sometimes there will be only 1 when the vertex is on the x-axis. Sometimes there will not be an x-intercept. In this particular example, I have 2 x-intercepts, so I'm going to need to repeat this process twice. So what I will do is a 0 is an x-intercept. I'm going to press the button, so I press graph, and then I'm going to press the button that says 0. And it's going to ask me for a left boundary and a right boundary. So this x-intercept right here is between -1 and 0. So somewhere between -1 and 0 is this x-intercept. I'm going to hit find 0. So the first x-intercept is at -0.78 when I round to the nearest hundredth. So I'm going to put a comma because I'm going to go find the second x-intercept. I'm going to hit OK. I'm going to go to 0. The second x-intercept is over here. It's somewhere between x equals 1 and x equals 2. So somewhere between 1 and 2 is this other x-intercept. It's important that your left boundary is the smaller number, that your right boundary is the larger number, and that in between these two is that x-intercept you're looking for and only that one x-intercept. So we're going to hit find 0, and this is going to round to 1.28 is my other x-intercept. I'm going to hit check. Excellent. Let's try another one. So once again, open up the calculator. Once again, click the y equals button. Type in the equation. This time it's 3x, and then exponent button squared, arrow to the right to get out, plus 4x minus 2. I'll hit graph. Okay, I've got 2 x-intercepts. I'm going to find both of my x-intercepts, and then I'm going to show you how to find the vertex. So for my x-intercept on the left here, we'll press 0, and this x-intercept is between -2 and -1. Those are -2 and -1 is where that x-intercept, it's in between those two numbers. -2 is on the left, that's the left boundary. -1 is on the right, that's the right boundary. So that x-intercept is at -1.72 approximately. We're going to round to the nearest hundredth. And then I'm going to hit OK, and I'm going to hit 0 again because I have a second x-intercept over here. And this time, this x-intercept is somewhere between 0 and 1. So between 0 and 1, where is that x-intercept? Hit find 0. It happens to be at 0.39 if I round carefully. To find the vertex, let's go ahead and hit OK. The vertex is an extrema, so we're going to press the extrema button. And my vertex, the x value, it's somewhere between -1 and 0 is where my vertex is, somewhere in that neighborhood. And since it's a minimum, it's at the bottom of an upward-facing parabola, I'm going to look at the coordinates of the minimum. So in this particular case, it would be negative 0.67, comma, negative 3.33. It's worth noting that with your X-intercepts, you only list the X coordinate. With your vertex, you list both the X and the Y coordinate. Last example, I'm just going to do the vertex. So I go to my calculator, go to y equals, and I type in negative 3x, and then squared, arrow to the right, plus 9x minus 8 graph. Oh, and this one is interesting. It does not have an X-intercept. So for X-intercept, I will click none. And then for the vertex, I will click extrema. And my vertex is somewhere between x is 1 and x is 2. My vertex is, get an x coordinate right here between x is 1 and x is 2. Find extrema. This time, my parabola opens down. So my vertex is going to be a maximum. So I'm going to look at the coordinates of the maximum, which would be 1.5 and then negative 1.25. And that's how you do it.